A is a real number, and 4 to the A plus 8 to the A equal to 36. Find the value of A. Solving this problem, we can say 4 to the A by power rule. If we have x to the n, it is equal to x to the m n. By power rule, I can say 4 is 2 squared to the a, and I can say it is 2 to the 2a, and we can write it as 2 to the a squared. So I consider 2 to the a as y, or we can consider it, yes, it's okay, y. So we can say it is y squared. 8 to the a, similarly, we say 8 is 2 cubed to the a, so it is 2 to the 3a. And we can say it's 2 to the a cubed, so it will be y cubed. Now, our main equation is 4 to the a plus 8 to the a equal to 36. If I call this 1, I call this 2, then from 1 and 2, we conclude what? Here, 4 to the a is y squared. So I can write the first one y squared. 8 to the a is y cubed, and it is equal to 36. If I take all things to the left hand side, y cubed plus y squared minus 36 equal to 0. So the degree is 3. When we see degree is 3, we don't like that, because we like to work with degree 2, that we have a formula, quadratic formula. So when we have this, one of the most useful ways is to find at least one root. And we check small numbers. For example, y0 doesn't work, plus 1 doesn't work, minus 1 doesn't satisfy, plus 2, 8 plus 10 doesn't satisfy, minus 2 doesn't satisfy, plus 3, 27 plus 9, 3 works. So, because y3 works, let me write here, y equal to 3 works. So we can say 1, we can factorize, and 1 factor is y minus 3. I want to create y cubed, so I place y squared here, then I have y squared minus y cubed minus 3y squared. Now I want to reach y squared, so I place plus 4y. It will be plus 4y squared minus 12y. So for reaching negative 12y, I don't have y here, I should cancel that. I place plus 12 equal to 0, and that's good. Here, we can conclude the product of two terms equal to 0. So, maybe the first one is 0 or the second term is 0. We consider both cases. Case 1, y minus 3 equal to 0. So, we conclude if you take at plus 3 to both sides, y equal to 3. Y was what? Was 2 to the a, and we want to find a. So y is 2 to the a, so 2 to the a equal to 3, and by the definition of logarithm, a will be log of 3 with base 2. It's the definition of logarithm. So one answer is this. Now, let's consider second case. This term is 0, y squared plus 4y plus 12. Case 2, y squared plus 4y plus 12 equal to 0. Now, I solve this with two ways. I want to prove we don't have any answer. The first way, I use this identity, a plus b squared is a squared plus 2ab plus b squared. So, for using that, it's solution number 1 for this part. I say y squared plus 4y. If you pay attention here, y squared 2y times, so we understand b is 2. So you say plus 4. And because here we have 12, so 8 is left, equal to 0. So y plus 2 squared is this part, plus 8 equal to 0. What contradiction? Because we conclude y plus 2 squared equal to negative 8. We know y plus 2 squared because it is squared greater than equal to 0, plus negative 8 is negative. So we don't have any answer. If I want to solve this with solution number 2, let me erase this part. We have a formula. in a quadratic function that if a, for example, x squared plus bx plus c equal to 0 and x is real, we define discriminant or delta as b squared minus 4ac. One necessary condition, it has to be greater than equal to 0 if x is real number. Now, because a is real, we know y equal to 2 to the a. A is real, so y is real number. Here, our equation is this: y squared plus 4y plus 12 equal to 0. Here, if I want to calculate the discriminant or delta, it will be, pay attention here, b squared, this part squared, so here 4 squared minus 4ac or ac. Okay, so I can write minus 4, a is 1 here, coefficient, and c is 12. It will be 16 minus 48. Obviously, it's less than 0. If you want, you can calculate this. It will be negative 32. So it is less than 0. So we don't have any real answer for y. With both solutions, solution number 2 is more general. Solution number 1 needs to pay attention to perfect square to reaching a square number. So we solve these two ways, and our only answer is a equal to log 3 with base 2. Okay, please don't forget to subscribe, turn on the bell, and like the video, and I will release other ideas in my next videos. Thank you.